this lesson is going through a new concept of the natural exponent, e. We use e a lot. It's got a special property. And basically e is kind of like the number pi, where it equals a decimal value that goes on forever. It's irrational, and we'll talk about that more in a second. Okay, so as you know, for any number b bigger than 0, y equals b to the power of x has the following shape, this exponential function shape. Okay, this is because b to the x is bigger than 0 for all b bigger than 0. For instance, if b equals 2, then 2 to the power of x is always going to be bigger than 0. Think about that for a second. 2 to the 5 is 32, that's bigger than 0. 2 to the half is root 2, that's about 1.4 blah blah blah, that's bigger than 0. 2 to the negative 1 is a half, which is still bigger than 0. So any positive number to any power of x is still bigger than 0, which is why this curve here is always above the x-axis. Okay, so e is a special number with many mathematical properties that will be explored in topics such as logarithms and calculus. So here it says e equals approximately 2.7183, and then it goes on forever. I don't even know what the next numbers are. It just goes on forever without any pattern. So it cannot be written as a fraction. Therefore, like pi, e is an irrational number that goes on forever. To find the value of e on your calculator, you can press the e to the x button, but the calculator may be expecting you to put a power after the e. So you could put a 1, because e to the power of 1 is just e. And then if you press enter or equals, you should get 2.7183 and whatever other numbers show up. Okay, so let's try question 1. It says, find to 3 significant figures the value of the cube root of e. So this is just a calculator question, so this is just practicing on your calculator. So enter that into your calculator. You can either use your GDC or your scientific, either one is fine. For the first one, I got it was actually 3956 ... Now to 3 significant figures, I want 1, 2, 3 numbers. Now because this number here is 5, we have to round up. So if I add 1 to the 9, think of it more as adding 1 to the 39, and that becomes 1.40. Hopefully you remember with significant figures, you have to put the 0 in, otherwise it's technically rounded to 2 significant figures. Now, if you had trouble doing that on your GDC, well, for instance, on your scientific calculator, you had to press Shift, then the root button to get the cube root, then press Shift LN to get the E, and then it was expecting a power, so you just put a power of 1. So it looked more like this on your calculator, on a scientific calculator. Now on your GDC, make sure you don't use the letters at the bottom, where the whole alphabet is. If you use that E, it's considering it to be a variable. It isn't considering it to be this particular E. So on your GDC, you would press Control, and then the little power button, which then becomes the nth root button. Put a 3 where the n is. And then you would, inside the cube root, you'd press the EX button. There's actually a button that looks like that. So put that in there, and then it should be asked for a power, so put a 1 in there. So that's what you'd press on your GDC. And then next it says, find e to the power of 4. So that on your scientific calculator, press Shift LN and you'll get E, and then you'll need a power, and then put 4 into the power, like that. And then you would get 54 point, now to round to 3 significant figures, well it actually is this, 598 ... For 3 significant figures it should be 54.6. on your GDC, you would just press the e to the x button and then put a 4 in the power and then press enter. Now, here we're being asked in question 2 to simplify e to the 0.12 all to the power of a quarter. Notice it didn't say find the value of or calculate. We're just simplifying, so we need to simplify the power. Now, using our indice laws, this becomes e to the 0.12 times a quarter, because you times the powers when it's power to a power, and that becomes e to the 0.03, and that's as simplified as we can get it, so we're just going to leave it like that. And then question 3 says, write the following as a power of e. So in other words, I want this expression as just e to the something, I don't know what yet. So, first of all, this expression is e to the 1 over e to the square root of e can be written as e to the half. But I'm dividing those terms, so you can think of it as e to the 1 minus a half, because when you divide two indices or two base numbers, two indices with the same base, you minus the powers. And 1 minus a half is a half. So I'm going to leave it as e to the half, because it says write the following as a power of e. Because it says as a power of e, I've got no reason to go to the next line, which is root e. They didn't want it like that. If they wanted it in insert form, I would put it like that. But because they wanted it as a power, I would leave it as e to the half. So I'm going to rub out that last line. Okay, question 4. This is more like a real-life application example. The amount of bacteria in milligrams in a dish is given by BT equals 3 times e to the 2t, where t is the time in hours after the bacteria was planted. Find the amount of bacteria after t equals 0, or like 0 hours. So b of 0 would equal 3e to the 0, because 2 times 0, this power here, is just 0. And e to the 0, anything to the power of 0 is 1. So 3 times 1 is 3. Okay, b of 1 is 3e to the 2 times 1 is 2. And now, given that we're going to have to graph that in a minute, I'd like it as a decimal. So put that in your calculator. 3 times e squared is 22 about 0.2. And then when t is 2, b of 2 equals 3e to the 2 times 2 is 4, 163.8. Now sketch the graph of bt. So we can just use the values that we just found to graph the exponential function. Okay, when time was 0, we got a value of 3. That's pretty low. That's like down here somewhere. And then when time was 1, we got 22. That's about here. And then when time was 2, we got 163. That's all the way up here. So that's a huge increase. So our exponential function looks something like that. So that there is b equals 3e to the 2t. And notice we should probably label our axis that this is t and this would be b. So that's the graph there.